Hi, everyone. I would like for us to do a review of the broad topics that have been identified by CSEC to be tested this year. So I wanted to go through each of these topics and just do quick reviews to highlight the significant areas of the content that you need to pay special attention to, because these areas are highly testable. So this is extra time tutoring. Welcome for persons who are new, and we prepare students from 4th form up to upper 6 for chemistry and biology. So we are looking at the CSEC chemistry reviews, and this is our first session. So one of the first topics that were listed was atomic structure. So I have gotten the objectives from the syllabus. So really and truly, when you are studying, you must study with the syllabus, because you have to see what are the objectives underneath that topic so that you cover it adequately. So under the atomic structure objective from the syllabus, it says you are to be able to describe with illustrations the structure of atoms, starting from those with atomic number 1 to 20. And you have to see the atom as consisting of 3 basic particles: protons, neutrons, and electrons arranged in shells. And you also need to state the properties of electrons, protons, and neutrons, the properties related to the relative mass and relative charge only. So we also need to know to state the properties of electrons, protons, and neutrons, which are the subatomic particles found inside of our atom. So we will be discussing those. We need to define the terms atomic number and mass number. And we also need to define the terms relative atomic mass and see how it is related to carbon-12. We also need to interpret notations when we see elements and we see a number to the top left-hand corner. What does it mean? What does it mean when we see a number to the top, the bottom left-hand corner, to the top right-hand, and to the bottom right-hand corners? So we need to understand these symbols. We also need to speak about isotopes and list at least 3 uses of radioactive isotopes. So we will be going ahead to look at these objectives right now. And starting with the structure of the atom. All right, so first and foremost, I would like us to know that the atom is the basic unit of matter. All right, so the atom is the basic unit of matter. Right? So it usually can't be broken down into any smaller pieces. So it is the smallest unit that can participate in a reaction. Of course, we can't see the atom because it is so small, right? But the important thing to note is what is inside of the atom. So the atom is made up of subatomic particles. All right, so there are subatomic particles inside of the atom. All right, so what are these subatomic particles? As you can see there, we have protons. So protons are found in the nucleus. So that area in the center of the atom is called the nucleus, right? And as it concerns our protons, they are positively charged, right? And they have a charge of +1, relative charge of +1. They also have a mass. So the mass of the proton is also 1, right? Then we also have our neutrons. So neutrons are also located in the nucleus. So they are found there with the protons. Now they have no charge. So they are neutral. Okay, but they do have a mass of 1. And as for the electrons, so the electrons are found orbiting the nucleus. So they're found orbiting the nucleus on energy levels, or I should say in energy levels, or we call them shells. All right. So as for the property of the electron, it has a charge of -1, but it is massless. All right. So with all of these being stated about the subatomic particles, you can see that for the atom we have here, you would have in the nucleus the neutrons and the protons, and then you would have energy levels surrounding the nucleus, and then on the energy levels is where you will find the electron. So the atom is made up of mostly empty space. All right. So the atom consists of mostly empty space with a dense central nucleus and the electrons in shells. Okay. Now, with that being said, we're going to see how we can basically draw the structure of any atom once we are provided with the number of protons, the number of neutrons, and the number of electrons. Okay, so there are some things I want you to note about the atom that really and truly the number of protons are very critical. Knowing the number of protons that are present inside the nucleus helps to determine what is the identity of that element. So if I give you an atom and I want you to tell me what element it belongs to, what you're going to look for is to see how many protons it has, because that determines the identity. Each element has a unique number of protons. Then in an atom, the atom has to overall be neutral, meaning that the number of protons and the number of electrons must be equal so that the positive charges can be counteracted by the negative charges, so that overall the atom is equal. All right, so let us look at this symbol that was given to us for an element, and we will see how we could actually go about drawing the atomic structure and see what are the pieces of information we can get from this. So if I give you an element and you see a number to the bottom left corner, this is telling you the atomic number of the element. So the atomic number tells you the number of protons, all right? Now, the fact that I don't see a number here, so normally what would come here would be the charge, all right? So if you don't see a number there, it means the substance does not have a charge. All right, so I don't want to put that there. So let's say the charge would normally be found here. So there is no charge present. So we can assume that this atom is neutral, right? So this atom is neutral. And that would mean that the number of protons and the number of electrons should be equal. So when you have a neutral atom, then this atomic number here, it tells you the number of protons, but it also tells the number of electrons as well, right? Because the number of electrons have to be equal to the number of protons for there to be no charge in the element, for them to counteract each other. So therefore, I can see that if I have 8 protons here, right, number one, remember the protons tell you the identity. So if I have 8 protons, I would look at the periodic table to see what element has 8 protons and then determine its identity. So based on this periodic table that I have here, this is the periodic table for the first 20 elements. So therefore, if I have an element X who has 8 protons, I'll search and I'll see that that would correspond to oxygen. All right, because oxygen is the element that has 8 protons. So if element X has 8 protons, then it has to be an atom of oxygen. So remember, the proton number helps to identify what element it is. So it is oxygen. We also know that it also would have 8 electrons. right? Because this is neutral, okay? So what does it mean? So the 8 protons have an 8 plus charge. So there's a positive charge of 8. And if we also have 8 electrons with 8 negative charges, you can see how they counteract each other and it becomes 0. And so the atom is neutral. All right, so this number tells us the atomic number. This number of the top tells us the atomic mass. So the atomic mass tells us the number of neutrons and the number of protons. All right, so sometimes you will see the symbol A representing atomic mass and the symbol Z to represent the atomic number. All right, so the atomic mass tells us the total number of protons plus neutrons in the nucleus. All right, so remember the electrons don't have any mass. So it basically is telling us how heavy the atom is, right? So we add them together, we would see that if we have an atomic mass of 16, then we know that we already had 8 protons. So how many neutrons would we have? So it's easy for us to work out how many neutrons we have in an atom. What we do is we subtract the atomic number from the atomic mass. Remember the symbol for atomic number is Z. So if the atomic mass is 16 and the number of protons is 8, then it means that we had 8 neutrons. All right, so basically from this symbol, we could see that we had 8 protons, it was oxygen. We had 8 electrons because that had to be present to counteract the 8 plus charges to make sure the overall thing was neutral, because we didn't see a charge here. So it must have been neutral. And then this 2 down the bottom, what does that 2 represent? So this 2 now represents the number of atoms in a molecule. So when you see a number there to the bottom right-hand corner, then this is telling you that these elements join up to form molecules, and it's telling you how many atoms are present in a molecule. So oxygen is going to exist as O2 molecules. So you will have 2 oxygen atoms bonded together in order to create an oxygen molecule, right? So you won't find oxygen by itself. So that's what that number there is indicating, okay? Now remember, you must know the first 20 elements. Elements are arranged in a periodic table according to their atomic numbers. So it would start off with hydrogen with an atomic number of 1, then it goes to helium with an atomic number of 2, then lithium, then beryllium and boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Your job is to know the first 20 elements, all right, and the groups they are in. So these ones are in group 1, right? This one is in group 2. Well, this is not the real periodic table because they have eliminated the transition elements. This is in group 3, group 4, group 5, group 6, group 7, and group 8. And you are to know the special names for the groups. So group 1 elements are called alkali metals. We'll look at this some more when we look at our periodic table. The group 2 elements are called alkaline earth metals. All right, then we also have a special name for group 7 elements, which are called halogens. And then we have a special name for our group 8 elements, which are called noble gases. Okay. So noble gases are actually the ones which are the most stable elements on the periodic table because they have a full outer shell of electrons. So they don't really bond with other elements because they are stable. All right, I want us to consider now what happens when you actually have a charge. What happens when you have a charge? What happens when the number of protons and electrons are not equal? All right, before we even go into the ions, let me just ask this. So if I gave this element and it has an atomic number of 16 and a mass of 32, would you be able to tell me the number of protons, neutrons, and electrons, right? So first and foremost, you could identify this element because if you look at the atomic number, which is 16, you could go back up to the periodic table and see that if you have an atomic number of 16, that means you are sulfur. All right, so this would be an atom of sulfur. All right, let's look at the number of protons. So the number of protons would be the same thing as the atomic number. So that would be 16. The number of neutrons would be equal to the mass number, which is 32 minus the atomic number, which is 16. And the number of electrons would also be 16 because it would be the same thing as the protons. So now you could be asked to draw this atom here. All right, so if you are asked to draw the atom, there's something that I want you to bear in mind. You have to know how many electrons can fit on the various shells. So when you're drawing the atom, you have to be aware of the electronic configuration. All right, so please note that the first shell can hold a maximum of 2 electrons. The second shell can hold a maximum of 8. And the third shell can hold up to 18, but at the CSEC level, we still say it holds 8. All right. So before I draw the atom, I have to figure out the electronic configuration. So if I have this element X with 16 electrons, I have to see what would be the configuration so I can know how many shells I am to draw. So with 16 electrons, I put the first 2 on the first shell. Then I'd put 8 on the second shell. So that means I would have used up 10. And then on the third shell, I'd put 6. So it therefore means I should draw an atom with 3 shells. All right, so I'm going to do that now. So the first one I draw is actually going to be where I'm going to put my nucleus there. So I want to tell how many protons and neutrons I have. And then I'm going to draw my first shell. All right, let me do this again. All right, so let's put the first shell above this one. All right. And then I'm going to put another shell. So remember, we need 3 shells in total. Okay. So we need a 4th, we need another one. That will encompass these. All right, so not the best, but we can understand. So in my nucleus first, I want to make sure I know that I did have 16 protons and I did have 16 neutrons in the nucleus of the atom. So that's always something you should write: 16 protons, 16 neutrons. Now, as for my electrons, no, I'm going to start on my first shell. So my first shell has 2. So let me just put my 2 electrons. I'm just going to use X's to represent them. And then the second one has 8. So when you're putting on electrons, you should put electrons to the 4 corners first before you start pairing them. So I put 4 and then I have 4 more. So then I'll pair. So like it's as if I have 4 pairs. And then on the final shell now I have 6. So I put 1 at each corner first and then I pair. So this would be the structure of my element if I was asked to draw the atom itself. All right. So I'd have to put my nucleus in with my 16 protons, my 16 neutrons, and then I'd put my electrons on the various shells. Okay. So you should be able to be given a symbol and you should be able to draw that element, right? And as we said before, we know that this is sulfur because the atomic number helps you to identify the substance. All right, so yes, let's now continue to look at what about when we lose or gain electrons. All right, how is that going to change the whole picture? All right, so now we will look at our cations and anions. All right, so when we have lost or gained electrons, then the atom cannot be said to be electrically neutral anymore because you will have an imbalance between the number of electrons and protons. So for example, this element here has 4 protons. So if you have 4 protons, then you will be an atom of beryllium, right? So remember, your proton number identifies what element you are. So this is beryllium. With its 4 protons, and it has 3 electrons. So normally you would expect that if you have 4 protons, you would also have 4 electrons, but it simply means that this substance has lost an electron. All right. This diagram is not the most accurate, to be honest, because beryllium should have had 2 electrons on its inner shell and 2 on its outer shell. But this is just to show you that if you have more positive charges than negative charges, then you are a positive ion called a cation. And if you have more electrons than protons, then you are a negative ion called an anion. All right, so I want to walk you through when are you going to be able to form cations versus forming anions. All right, so first and foremost, our metals are elements with 3 or less electrons on their outer shell. And then outer shell is also called the valence shell. No. So for example, if I gave you aluminum, aluminum has an atomic number of 13. So if you worked out its electronic configuration, it would have a configuration of 283. So this is the outer shell of aluminum. That's called its valence shell. So now if you have 3 or less electrons on that outer shell, you are a metal. Now what elements want to do is that they want to look stable. So all elements want to achieve a stable configuration, and they want to look like noble gases. And noble gases have a full outer shell, all right? Remember, the noble gases were the elements in group 8. Now, for that to be achieved, in this case, as a metal, it would be easy for you to lose your outer 3 electrons, and then your outer shell will now be your second shell. So if aluminum should lose 3 electrons, it will develop a 3+ charge, because this would now have lost the 3 electrons from the outer shell. So this will now be the configuration of the aluminum ion. So why does it have a 3+ charge? So let us work it out. So remember, it had 13 protons originally. It also had 13 electrons originally. So at this point, it was neutral, all right? So this is when it was an atom. But when it went ahead and lost 3 electrons, it still has the 13 protons, but now it has 10 electrons. So now we have an excess of positive charge versus negative charge. So we have an excess of 3+ because we have 3 additional protons versus electrons, hence the reason why it develops a 3+ charge. So these ones which develop positive charges are called cations, all right? So aluminum there would form a cation. All right, so then any element, as we said, with 3 or less outer electrons, they would lose that outer shell, and with those outer electrons, and then the next shell coming up would be full, and they would look like the noble gas. In fact, this looks like neon. So neon is a noble gas. Neon has 10 electrons and it has a configuration of 2,8. So when aluminum loses its outer electron, it actually looks like neon, which is a noble gas. So the elements, they form ions because they want to look like noble gases, all right? So let's look at the ones that are going to form anions. So anions now are going to be formed by nonmetals. All right, so these are formed when nonmetals. And what are nonmetals? Nonmetals are elements with 4 or more electrons on their outer shell. So elements with 4 or more valence electrons. These are the ones that will want to gain electrons to form anions, all right? So they gain electrons to the valence shell, which is the outer shell. All right, so let us look at an example. So for example, say I had oxygen. So oxygen has an atomic number of 8. So when I work it out, there will be 2 electrons on the first shell and 6 on the outer shell. So therefore, because oxygen has 6 electrons on the outer shell, it is in group 6. So remember, oxygen wants to look like a noble gas. It desires to have a full outer shell. So it wants to have 8 on its outer shell, but now it has 6. So oxygen simply needs to gain 2 electrons to develop a 2 minus charge, and then it would be called an anion. And it would actually have a full outer shell just looking like neon. All right, so now why does it develop a negative charge? So if we look at what was there originally, all right, originally, if we had 8 protons, we would have also had 8 electrons, okay? And that would have meant that the positive charges would have canceled the negative charges. It would have been 0 and the atom was neutral. But it gained electrons. So if you gain 2 electrons, that's now going to create an imbalance because you're still going to have your 8 protons, and then you now have 10 electrons. So you can see that you have an extra 2 negative charges versus positive charges. So that's why you end up getting a -2. So the essence is that when atoms gain electrons, they develop a negative charge depending on how many electrons they gain. And those would be the anions. And non-metals are the ones who gain electrons, and metals are the ones who lose electrons to form cations. All right, so let us now see if we can put this into practice. I'm going to be drawing an atom or an ion, and we are going to figure out what atom it is, what group it is, what ion it has formed. All right, so I'm going to draw my nucleus first. Say I'm going to put, I'm going to have 16 protons in my nucleus. I'm going to have 16 neutrons, right? And then I'm going to draw my shells now. So we are going to figure out what is it I'm drawing. Is it an atom? Is it an ion? What's happening with it? All right. So I'm going to put my, sorry, let's leave that. So that's the nucleus right there. So let me put my first 2 electrons on the inner shell. Then I'm going to put 8 electrons on that second shell. Remember, we put the electrons at the various poles. All right. Now, look, I'm going to put 1. Let me see. Okay. So I'm going to put 8 electrons on the outer shell. So we are going to figure out what element this is first and foremost. The first thing is that I would look at the number of protons. If you have 16 protons, then it means you are sulfur. All right. So I'm going to say originally, how many electrons did it have? Before I even look at the electrons on the shell, the number of protons would have been 16. And so the number of electrons would have also been 16. So I would expect that the original configuration of this element would have been 286. So if I have an element which has 16 protons, I'm expecting it to have 6 electrons on its outer shell. However, when I actually look at this atom that I have here, or this diagram that I have here, I see that it actually has this configuration. It has 2 on the first shell, 8 and 8. All right, so what happened? This is clearly not an atom. This must be an ion because it should have had 6 electrons on its outer shell, but it has 8. So the only way that could have happened is if it had gained 2 electrons. So what I am actually looking at is that I am looking at an anion. So this is an anion of sulfur because the number of electrons and the number of protons are not the same. All right, so I know that it must have gained 2 for it to have 8 on the outer shell. Now, because it has gained electrons, when you gain electrons, you develop a negative charge, and you gain 2 electrons, you develop a -2 charge. So essentially what I drew for you here was an anion of sulfur. All right, so essentially from what we have covered so far, as it concerns the atomic structure, you are supposed to know, let me go back up, just let us remind ourselves of what we have covered. So first and foremost, we needed to know that according to the objectives, and we're going to be looking at the isotopes and the uses in another module. So we'll look at isotopes separately. So what we have covered thus far from the objectives is that we have been able to describe the atom, right? And we should know from elements 1 to 20, we should be able to draw them with the nucleus, with the protons and the neutrons in the nucleus, and the electrons, and we should know how many electrons should be on how many on which shell. We have also stated the properties of the protons, neutrons, and the electrons. We know what the atomic mass and the atomic number is. We're going to be dealing with this objective when we deal with isotopes as well. So we're going to deal with what is the relative atomic mass. So we have covered this notation here, how to interpret these notations, what these symbols mean. So we are going to be looking at these 3 in our next video. We're going to be looking at defining the relative atomic mass, defining isotopy, and the list and uses of radioisotopes. But as I said, we spoke about the atom, that it was this basic unit of matter, that it does contain neutrons and protons in the nucleus, and that it has electrons orbiting the nucleus on the shells or in energy levels, and that these particles are called subatomic particles. We have the protons, we have the neutrons, right? So our neutrons are the ones that we said they don't have. Just a minute, let me correct this. So the neutrons, they don't have a charge, but they have a mass of 1. Electrons are found orbiting the nucleus on energy levels or shells, which has a charge of -1, but is massless. The atom consists of mostly empty space with a dense central nucleus, and the electrons are on our shells. And then we went on to look at the notation of our elements. So we said if we have a number to the top left-hand corner, that's the atomic mass, which is the combination of protons and neutrons. To the bottom left-hand corner, that's the atomic number, which is the number of protons, and it also tells you the number of electrons if it is neutral. We said to the top right-hand corner would have been the charge. If there is no charge present, you assume this is neutral. And then this number to the bottom right-hand corner would be the number of atoms in a molecule. All right, so we had looked at the first 20 elements. We looked at how to determine if our element is neutral, right? How to calculate the number of protons, number of neutrons, number of electrons. Remember, you are to know the first 20 elements. And then we also went on to look at the electronic configuration, how to draw our atoms, how to know when we are looking at ions, which are either cations or anions, right? So we said metals are the ones which form cations by losing their outer electrons, and anions are the ones that form negative ions by gaining electrons. And we looked at an example here of a diagram, and we were able to deduce that this was an anion of sulfur because it had an electronic configuration of 288, which means it had gained 2 electrons. So this is our first revision video. We will continue with the next objectives when we look at our isotopes.